Welcome back to Medinare. In this video, let's discuss about water purification. As we know, the water that we get from various sources are more prone to contamination and is not suitable for human consumption. Therefore, it must be purified. Purification of water is done by various methods which can be categorized as purification done on a large scale and purification done on a small scale. On a large scale, purification of water is mainly done by three methods, namely storage, filtration, and chlorination. Let's see how storage does its job of purification. As a result of physical, chemical, and biological actions taking place in the stored water, it gets purified to a certain extent. Almost all impurities settle down within 24 hours due to the gravity, making the water more clear, allowing light penetration. Chemically, the aerobic bacteria oxidize the organic matter present in the water with the help of dissolved oxygen, thereby reducing the content of free ammonia and increasing the concentration of nitrates. Biologically, during storage, the pathogenic organisms gradually die out. However, if the water is stored for a long period of time, there is likelihood of development of vegetable growths like algae, which imparts that bad smell and color to the water. The next way to purify water is chlorination. Chlorination is the process of addition of chlorine to the water. Remember, chlorination is a supplement and not a substitute to sand filtration, about which we will talk about in the next video. So what does the chlorination do? When chlorine is added to water, there is formation of hydrochloric acid and the hypochlorous acid. The hydrochloric acid is neutralized by the alkalinity of the water. The hypochlorous acid ionizes to form hydrogen ions and hypochlorite ions. The disinfecting action of chlorine is mainly due to the hypochlorous acid. Chlorine acts best as a disinfectant when the pH of water is around 7 because that's when the predominance of hypochlorous acid is seen. Chlorine has the ability to kill bacteria but not spores and viruses until used in high doses. It oxidizes iron, manganese, and hydrogen sulfide. It even destroys the taste and odor producing constituents and controls algae and slime organisms and even aids in coagulation. Chlorine is applied either as chlorine gas, chloramines, or perchloron. Chlorine gas. It is the first choice because it is economical, quick in action, efficient, and easy to apply. However, it is an irritant to the eyes and it is poisonous. Chloramines. They are loose compounds of chlorine and ammonia. They have less tendency to produce chlorinous taste and gives a more persistent type of residual chlorine. Perchloron. It is also called high test hypochlorite and it is a calcium compound. I'm mentioning it again. Do remember that chlorination is not the only step to purify water and is always a supplementary method to sand filtration. We have certain principles regarding chlorination and now let's have a look at them. The water to be chlorinated should be clear and free from turbidity. The term chlorine demand refers to the difference between the amount of chlorine added to the water and the amount of residual chlorine remaining at the end of specific period of contact at a given temperature and pH of the water. Breakpoint chlorination. The addition of chlorine to a point at which the chlorine demand of the water is met is called the breakpoint. If further chlorine is added beyond the breakpoint, free chlorine begins to appear in the water. The free residual chlorine should be present for a contact period of at least 1 hour to kill the bacteria and viruses. The minimum recommended concentration of free chlorine is 0.5 mg per liter for 1 hour. The free residual chlorine provides a margin of safety against subsequent microbial contamination which may occur during storage and distribution. The sum of chlorine demand of the water and the free residual chlorine of 0.5 milligram per liter constitutes the correct dose of chlorine to be applied. We also have another term called superchlorination, which comprises of the addition of large doses of chlorine to the water and removal of the excess chlorine by dechlorination. This method is used for heavily polluted river water. And that brings us to the end of the video. I hope you guys found it helpful. Do like this video and subscribe to Medinare for more. Thanks for watching.